things. And we call this Pump It Up for obvious reasons. I do have a special guest, and you can see him. He's one of the Hollywood Squares, Mike T. And then, as I think you already know, myself, because we've done things before. And, you know, I'm a licensed landscape architect. I'm also a licensed contractor by trade. So we try to, you know, I love to include Mike as much as I can because that's what Mike does. He's our expert with pumps. So what we'd like to do to go over, and we're happy, again, we can send you the video, the presentation, whatever it is that you need, is how to specify a pump. We're going to go through some pump basics, some project examples, the job information form. We also call it a JIF form. Provided specs, what we actually provide as a manufacturer, and what the lead time is. So those are the basics on that end. But first off, on the pump basics, we probably should identify some of the different components and how it actually works. Now, what would be nice, Mike, I don't know if you're set up for this or not, but what would be great, well, do you have a pump there at your place?
Yeah, absolutely, Mark. You know, once we know we are going to have this webinar, we already set it up. So it's actually on my driveway. So I'll be happy to.
All right. Well, hey, it'd be great if you could show us, because I just think it'd help to have you, you know, describing everything on there so we know what's going on.
Absolutely. Yeah, just give me 30 seconds. Let me walk out and then I'll join back on my camera.
Okay, we'll give you 20, but yeah, go ahead. So Mike, he covers all of California. And so almost, well, really pretty much every specification job that we have, he's involved with one way or another, whether it's on the initial design, and it actually can be even, you know, checking in to see what the time frame is, you know, for the contractor to get that, and so on. So can you see, hopefully you can shake your head if you want, Alyssa, like you sort of see him, and hopefully it's a big enough picture on your screen. If not, it covers the screen pretty well. Awesome. Mike, hey, can you hear us?
Yeah, I can. Can you guys hear me?
Yep. We can hear you.
Perfect.
Hey, so you really do have it on the driveway. It looks like you polished the thing or something.
I did, yeah, absolutely. So, you know, it's my baby, so I try to take care of it. So, awesome. So let's go through some the basic components of the pump station. So what you see here is our most value engineered pump station. That's our CLP version. So this one comes as you see, it has a package system with an enclosure and all the components inside the pump station itself. So in order to give you a basic idea, I'll start with the main components. So one of the main component is the electrical box. That's the main disconnect switch where the main power from the site comes into. We can have pump stations rated for different voltages and phases. So this one, as you can see, it's rated for 480 volts and 3-phase. So we do have pump stations which are rated for 208 volt single phase or 3-phase, or 230 volt single phase or 3-phase. So, you know, when contractor orders it, they gave us that data and we designed the pump station accordingly. Or, you know, at the time of specification, if you can let us know what is the power available, we can specify the pump based on that. The next main component, like you see here, this is the inlet of the pump station. So the pump is mainly installed after the backflow. So from the backflow, the plumbing comes to the inlet of the pump. We do have an isolation valve, which is the inlet isolation valve. Then comes the inlet pressure gauge. What you see here, the green component is the actual pump, which is the heart of the pump station. And after the pump comes the discharge line, which goes out to the discharge to the main line. So the flow sensor and the master valve comes after the discharge line of the pump station. Also on the discharge line, we do have a couple of other components. We have discharge isolation valves. We also have a discharge pressure gauge, which actually shows how much discharge pressure we are boosting to the main line. So far, do you have any questions? There's a couple more other components, which is the VFD. It's a variable frequency drive, and also a pump start relay, where the signal from the irrigation controller comes to. So it'll be hardwired to the pump start relay here. That's where the irrigation controller signal comes in to turn the pump on. And the VFD, and here's the pressure transducer, which actually makes sure the pumps ramps up or ramps down, keep the pressure constant, and provide enough flow rate depending on different valves or zones in the irrigation in the site. There's a couple of other options to start the pump. So like you said, one is the pump start relay, which is the clock start or irrigation controller start. We also have something called a flow start kit, or it's a flow start. So just in case if the irrigation controller is far away from where the pump location is, we can set it up as a flow start. So when the irrigation starts, the pump or this flow sensor actually pick up a signal of the flow and tells the pump to turn on and boost the pressure. So those are the main components and how the pump is being operated. So if you don't have any more questions, I can actually go on and we can look into different scenarios.
But when he's already back on, I thought, Mike, since you, I think, took some of these pictures, and why don't you show us a few different scenarios and start with this one. This one's more of a typical scenario that we have with landscapes. Is that not?
Right. Yeah. So boost is 80%, or I would say 90% of projects which we deal in California is boost application where a city provides certain amount of pressure at a site, and then if that pressure is not enough for the efficient operation of irrigation, we actually boost it. So as you can see in the picture, there's a backflow right there in that green fenced area, fence box, and then comes the pump station. So for example, if we have 30 psi at the backflow dynamic pressure, we might need another 50 psi to boost. So when the pump boosts from 30 to 50, from 30 psi inlet, it boosts another 50, we will get a discharge pressure of 80 psi. So that's the boost pressure scenario right there.
Great. Let's go to the next one.
This is another scenario which is called, it's called an above ground tank or a flooded suction scenario where, I've seen mostly in Northern California, in San Jose area, where the city wants the water to be stored in a air gap tank like this. And we collect the irrigation water from these tanks to boost the pressure and go for the irrigation.
Is that supplemented too, Mike, like with just regular city potable water and the water in the tank, or is it just the water in the tank?
Just the water in the tank. So the city water gets collected into the tank and then for the irrigation, and then we boost it. from there. So, I mean, typically, unless it's really required for the site, we don't really promote it because, you know, if a city water has around 20 PSI or 30 PSI or whatever they have, you're bringing that available pressure to 0 or approximately 2 PSI when we are collecting in a tank. So for the irrigation, we'll have to boost from that low pressure to that, you know, whatever pressure we need. So we are losing all those available pressure by just, you know, collecting it in a tank.
Yeah. So the only pressure they really have is when there's water up here.
Correct.
Right.
And the other thing is there are some scenarios in Southern California. I see now it's called rainwater harvesting. So, you know, for any new buildings, which is in LA County, they have to have a rainwater harvesting system. So it could be either as we saw in the above ground tank, or right now, what you see in the picture right here, it's a below grade tank where we pull water from the below ground and pump it, boost it, and use it for irrigation application. So this is called a suction lift application.
Okay, great. What about the wet well?
Yeah, so these are mainly used for massive lake projects or parks, which has lakes and stuff, or sometimes these are also used in golf applications. So like I see, a pump station will be installed beside the lake. They will actually create a wet well beside the lake. So the water level in the lake will be approximately the same as the water well in the wet well, because they have a, you know, a intake line from the lake to the wet well. So it helps to keep that water level same between the lake and the wet well. And then we pump that water from the wet well for irrigation application. So, you know, we're talking about around 1,000 gallons per minute or higher flow rate application. Could be done for smaller too, but, you know, mostly what we see is for higher flow rate, big projects.
Okay. We like big projects.
Love it. Another scenario for a suction lift is, you know, we did something similar in Auburn Regional Park. So they did have a pump setup similar to the previous slide, but due to site conditions, they couldn't, you know, instead of building a new wet well, they decided to put a pump station on the brim of the lake. So like what you see in this picture, there is a suction line going into the pond, and the pump stations sit right beside the lake or the pond, and then we suck the water. We'll have a couple of filters also, because the water in the pond is not that clean. So we filter the water before it comes to the pump. Also, we filter the water downstream of the pump before it goes to the irrigation, because, you know, we need, without filtration, the irrigation lines or the valves and the rotors are going to get clogged. So we need to make sure the water is filtered. So, you know, saying that, Rainbird also manufacture filters as well. So we can provide an integrated solution with filtration as well, packaged in the pump station.
So that keeps all the big stuff out, like the fish and twigs and branches and people, all that kind of stuff.
Please.
Just want to be sure. All right. So I want to talk a little bit about the flow range. When we're filling out that GIF form, and I'll show you what that looks like. Typically, we need to get, actually always, we need to get a minimum flow and a maximum flow. With the minimum flow, with a lot more drip systems, it seems like about 90% of all irrigation in NorCal, at least, is drip. So now we've got lower flow, so we need to know what that minimum flow rate is so we can size the pump appropriately. Then also the maximum flow, what happens a lot of times when people fill out the GIF forms, they're only considering one valve at a time, where we know they have the capability and maybe they have the hydraulics to actually do, you know, 3 or 4 or 5 valves at a time. So we need to know what that maximum flow is for all those together, again, to size the pump correctly. Also, we need to know the available pressure that you have when you start. We need to know the static, which is what this is right now, is static pressure, versus dynamic would be like if I turn one of these guys on, the pressure in here would probably most likely be just a little bit less, but we need to have both of those, the static. And hey, Mike, since you're the definition guy, why don't you talk a little bit about the dynamic pressure definition?
Yeah, so, without reading all this, basically dynamic pressure is the pressure when the water is dynamic, basically water is flowing through an irrigation system. So for example, static pressure at a site, we have 6. When the irrigation is on, we have to consider the friction losses through the valves, through the pipes, through the backflow, and all the fittings and everything. And also we have to consider the elevation losses and any other losses. So actually the dynamic pressure will be lower than what we have static. So, when it comes to design stage, what we have seen is mostly the designers calculated in the critical loss calculations. So, we are already considering that. So then we will know if we need a pump or not, because if we don't have enough residual pressure available. So, coming back to the definition, dynamic pressure is the pressure when an actual, when the water is actually flowing through an irrigation system.
Perfect. All right, locating your pump. We know it's one, aesthetics can be really important, even though a lot of times we may want to see the whole thing. So there's a lot of different ways, whether it be, in a vault. And Mike, I was wondering if you had a couple different scenarios and, maybe talk about even some of the jobs that had custom paint.
Yeah.
Make it work.
Yeah, so we did a project for the air base here in Lemoore. So they did have request to paint the enclosure in a sand color, because that's what they wanted. So we do have the capacity to paint the enclosures or paint the pump stations to whatever color which the customer requests.
And we do that in Tucson, right, where we manufacture the pumps?
Correct. All the pumps are manufactured in Tucson, and that's where we do it all.
All right.
Yeah, and Mark, also to explain, so basically, please, could you go back to the last
Yes.
slide? Yeah. So, if the pump is installed inside a pump room, you don't need an enclosure because the pump room acts as an enclosure. But if it's installed in the field, yes, that's where we recommend an enclosure, so it protects the pump station and the components from a vandalization or dust and rain and other stuff.
Great. Any questions, Alyssa, at all? You still good?
I'm good. I think my questions are coming up on your next slide about the voltage and the phases.
Oh, awesome. I know that there's probably quite a bit of information that we try not to make any assumption, but I know that you already know, and we know that you already know. But sometimes we just like to go over it that way. If you've got questions, you can let us know. But yeah, Mike definitely can handle the power specs.
I am curious about that pump inside the room. Is there any kind of ventilation you need for that if you put it indoors?
So yes, it does need ventilation. And also our pump stations, if it's like for in hot weather or in the cold weather, we can also provide insulation. And also we provide heat exchangers or air conditioners, depending on the size of the pump and size of the motor, size of the variable frequency drive and the components in the control panel. So to keep all the components ventilated, we do that. And there have been projects which we've done also where the customer didn't want to see the pump above grade. So they actually asked us if they can install it in a vault below grade. And yes, we have done that. So anytime you have projects like that, please let us know, and we'll get the right answers, like how much ventilation we need, what options we can put on the control panel to keep it ventilated, stuff like that.
All right. All right, power.
Power. So like I said earlier, this is one of the most important factor when it comes to the specification or before the pump station has been ordered or installed, because if the pump is selected for the wrong power, we're just gonna burn down probably a neighborhood or a transformer around there, depending on the size of the pump. So I know at the time of the spec, it's hard for a designer to know what is the voltage available or the space available. So what we recommend is always put a note in the spec that assumed power is so and so. For example, we can say the most common available is 230 single phase. So we would put that, and we will say contractor to confirm the voltage and phase available at the site before they order the pump station. So that actually protects you as a designer or a specifier, and also us as a manufacturer. And it gives some responsibility to the contractor to check the power before they actually order the pump station. So Rainbird, supplies pump stations all over the world. So, most common voltages, what we see in California is 208 volt, 230 or 240 volt, 460 or 480 volt, and single phase or three phase. So we can manufacture pumps for all those voltages. We just need to know what exact voltage and power, phase they have at the site before we actually start manufacturing. So what was your question, Melissa? Yeah.
And Mike, isn't the three-phase typically just a better way to go for energy conservation and than, let's say, going with a single phase?
Right. So when it comes to pump stations above 7.5 horsepower or about 10 horsepower, we save more electricity if we go with the three-phase pump, because the amps consumed on a three-phase pump at higher horsepowers are lesser. So the operational cost is lesser or lower when we go with three-phase. So even if the pump initially costs a little bit more, like, a couple of $1,000 more than single phase, they are going to eventually save energy by operational cost through the lifetime of the pump. So, typically the lifetime of the pump is like 15, 20 years when you put in a pump station. So three phase is recommended, but for new developments like home developers and stuff like that, they may not have three phase at the site. So we don't typically need it, but if they have three phase, it's well and good.
Great. So here's our job information form, or the JIF form. This is a PDF that we have, and I think we've probably already sent one to you guys, but this has been updated just within the last year, and it goes through all the different project name and all the information that we need so we can size the pump appropriately. The other nice thing that we've added to this recently is we can also identify, it makes it easier for the designer to identify what it is, or we can help them do that. So any of this that we're showing, we do it all the time. Let's say they can only get 3 items on here, then we'll go through and we'll help them, put that information in there so we can make sure we get the right pump. So once we have the right information, it's fairly easy to do. Now, another thing that we've done recently. We keep improving our website. So hopefully this will go. I linked it up to the pump area, and you can actually do the same thing as that GIF form. And you can come in here and launch pump station quick RFI. And you can go through this, and this will go to our pump group. And there's just 4 basic items on here and some easy pull downs, you know, whether you want to quote or help with design or whatever. And then you just go down to the bottom and you go to the next page. You can actually choose files. Like if you have specific files that you want to add to that might help us in the designing of the pump. And this goes right to the pump group, and then they produce a quote. So it's really handy to have this. Mike, has this been about, not that long, what, a year?
It's been about 6 months. And then also, Melissa, I want to say that just put in the information what you have and send it to us. And then always we can call back to you and let's discuss about the scenarios before we, select the pump. Like some of the options here on section 4, you may not be able to determine. So, but I can, we can discuss some questions. So for example, do we need a pressure relief valve, or do we need a, high amplitude flow meter, or what will be the budget for this pump for that project, or so we can pick and choose different options. We can discuss that and spec the pump accordingly. So just fill in whatever information you have, at least to start our discussion, and we can get the spec out for you based on that.
Great, and we can also do filtration actually the exact same way as this. And when we build it, we can build the 2 together, put them on a skid and have them come straight out to the site. So that's another really nice feature. So you're not having to coordinate between 2 different manufacturers. So it's good for design, warranty, and all the above. So this is something that we provide, once we have all that information right. And Mike, you want to go over any of this on the spec? This is pretty self-explanatory, but.
Yeah, so we will provide you with a detailed pump specification with a spec number, which you can call out on the plans. It will show the maximum flow rate, all the design parameters, design voltages and everything. And then also we'll provide you with the cut sheet of that pump, how it will look like. And, since you guys are awesome, we're also going to provide a drawing as well, so you can put it on the plans. Mark, can we go to the drawing slide? Yes.
Maybe.
So it'll be like a CAD drawing or a PDF where you can actually put it on the plan. So, we'll show the dimensions when it's going out to bid, so we try to make your job easier. Thank you.
So do we do that on a PDF, or do we use a sticky back?
All of the above.
Maybe the sticky back was before your time.
Yeah, it is.
I think you also need to detail that concrete section.
Yeah. Absolutely.
Our turnaround is really fast. If Mike wasn't here, I would probably cut all these hours in half. But the spec package, I work directly with Mike, and we work on projects, literally every week or so together. So the turnaround is good. And as long as we know, sometimes have an idea when you need it by, we can get it fairly quickly. It mainly comes down to the specifier to get us the right info. If we have that, we're pretty much there, and we can put together the cost and everything else. And then Mike's always there for any additional questions that I can't answer, but I do it together because I'm following the project because you're my landscape architect. I need to make sure that I know what's going on, and Mike always CCs me on everything. So it's really helpful having him. And then the manufacturing timing, still pretty quick, compared to others that I've seen. These are 3 to 6 weeks for small platforms, 6 to 12 weeks for larger custom platforms. So And it'd be great, maybe at one point, I don't know if you've ever been to our facility in Tucson. You know, of course, now nobody's going there, but when things get, you know, back up and running as far as doing a fly-in, that's a great place to go to take a look at everything that we have there, not just the pumps, but everything. So anyway, a lot of people are really impressed because the pumps, we actually, don't we operate each one, Mike, individually before they
Yes.
get out?
So yes, so we do all the testing, so hydraulically, not just hydrostatic. Hydrostatic is just pressure testing. So a lot of the pump manufacturers or pump station manufacturers, they just do a leak test just to make sure the station doesn't leak. But Rainbird does the complete performance test. So for example, if we design it for a certain flow rate, certain boost pressure, we actually test the pump for that specific data. And we have all the test records. Other thing, what Rainbird, because we do this, what Rainbird does is we are confident to offer 3-year warranty for our pump station. And we also give, something called we also offer a GSP support. So it's a remote support for the customer. It comes free with the pumps for the lifetime of the pump. So if there are some minor errors happening at the pumps, the customer can directly call our GSP support line. They can pull up all our test data and the startup data and everything, and try to help them to solve the problem remotely. So they get like quick support. And if it's not solvable remotely, then we can send a technician to the site.
Great. And then this one, of course, this is, as I was telling you a little bit earlier, this is what we tried to do, but we will try to do that again. Just bring the pump out to the office. Sometimes they don't have room in a parking lot. We've done anything from parking lot to garage structures where we had to get permit even to even bring it in there. It just depends on how things are, but we usually can get it there. So we do that. And then, this is my last pump guru, or just ask, Mike T. So he's always there. But I like this picture because it had the Spice Shop in the back. So I thought it was a good photo. But that's what we pretty much have. And we just wanted to give you like a good, thorough, hopefully overview